This is the last lecture for Unit 3 on sensation and perception. We are going to talk about binocular and monocular cues today. This is not just important for your test on Wednesday. You will need to know this information for the AP exam, and it's also going to help you for the project that you are going to be working on for this unit. So we'll start with binocular cues. Two eyes are definitely better than one. If you only had one eye, the task of seeing is going to become very different. And because our eyes are about 2.5 inches apart, the retinas in our eyes receive different images from the world. If you're sitting there focusing on something, close one eye, then open it and close the other pretty quickly. You're going to see that, in fact, our eyes do see different images of the world. Now, what happens is your brain compares those different images, and it helps us to judge relative distance. So with using our two eyes, we can assume or estimate at least how far or close something is to us. The images that are different from the two eyes, this is known as retinal disparity. Think of retina, and then disparity is difference. And your book talks about how you can kind of use your fingers and hold them out in front of you to create this floating finger sausage, and it helps to illustrate this idea of retinal disparity. Remember, retinal disparity is the images from the two eyes that are different from one another. Another binocular cue is convergence. These are neuromuscular cues. So if you've ever seen something floating towards your nose, or if you've ever held your finger out in front of you and slowly brought it into your nose, the binocular cue of convergence is going to make your eyes move inward towards your nose to see the near objects, and outward away from your nose to see the far objects. So you can see as this firefly is getting closer to this man's nose, his eyes are going to converge. They're going to turn inward to his nose. As the firefly is farther out, the eyes are going to turn away from the nose. So again, the two binocular cues you need to know are retinal disparity and convergence. Now, moving on to monocular cues. When we're trying to judge farther distances, we often use one of our eyes. Monocular cues means it's available to either one eye or the other. The first monocular cue we need to talk about is relative size. If two objects are similar in size, we perceive the one that casts a smaller retinal image to be farther away. So the smaller something is, the farther away we assume that it is. So these two pencils, we assume that because this one is farther away, it is smaller, or because it's smaller, it is farther away from us. In reality, they're the same distance to us. So another example of relative size, if you're a driver and you see a pedestrian in the distance, you're going to assume that that pedestrian is smaller than what they actually might be. This is why children are often subject to being hit by cars, because children appear farther away than they actually are because they are small in size. The second monocular cue that you need to know is interposition. This says that objects that block other objects tend to be perceived as closer. So if one object blocks our view of another object, we perceive it as closer. Now, this is going to confuse the figure ground Gestalt grouping principle we talked about in the last lecture. So you can see that the woman on the horse is blocking the tree that's behind her, so we perceive her to be closer to us than that tree. But of course, you have to distinguish with the figures in this picture, which would be the tree or the horse or the woman, and then the background or the ground. The third monocular cue is relative clarity. This says that because light from distant objects passes through more light than closer objects, we perceive hazy objects to be farther away than those objects that appear more sharp or more clear. So light from faraway objects passes through more atmosphere, and because of that, we think that things that are hazy are farther away. If you think about if you've ever driven in fog or snow, the car in front of you appears farther away from your car than what it actually is. So this is just saying that things that are hazy appear farther away. That's why driving in fog is so dangerous at times. Fourth binocular cue is the texture gradient. This says that closer objects tend to have a coarser texture than far away objects. So change from coarse distance. Texture is a fine, indistinct signal and distance. So if you were to look at your sweaters hanging up in your closet, you're going to probably just say, well, that's a blue sweater, that's a green sweater. But as you get closer to your sweater, you're going to be able to pick out the details, the texture gradient. So a shirt hanging up in the closet is going to look smoother. If you've ever looked at my desk in the classroom from far away, it looks as though the top of the desk is smooth. But in fact, once you get closer to it, you see that it has divots and things like that in it. Now, relative motion is probably the hardest monocular cue for you to understand by me verbally explaining it, but I guarantee at some point in time, if you've ever been a passenger in a vehicle or in a train, you have noticed the monocular cue of relative motion. This cue says that objects that are closer to a fixation point move faster and in opposite directions than objects that are farther away from a fixation point, moving slower in the same direction. So let's say that you're riding on a bus like this young woman is, and you fixate on the house. So the house is your fixation point. The closer the objects are to you, so this fence and this grass is closer to her than the fixation point. The closer the objects are to you, or if they are in front of the fixation point, they are going to appear to move backwards, while the objects beyond or farther away from the fixation point are going to appear to be moving with you. The next time you are in a passenger in a car, focus on something, have a fixation point, and notice that everything that is closer to you than that fixation point is moving backwards, and everything that is beyond the fixation point appears to be moving with you. We also have the linear perspective monocular cue. This is that parallel lines like railroad tracks appear to converge, remember that means coming together, appear to converge in the distance. The more the lines converge, the greater their perceived distance. So here you see what looks maybe like a subway terminal. These, in fact, are parallel lines, and it appears as though they are coming together down here at the end, when in fact they are not. This is linear perspective. The more lines converge, the farther the distance they are. We also have the light and shadow monocular cue. This says that nearby objects reflect more light into our eyes than more distant objects. And given two identical objects, the ones that are shaded on the top are seen as sticking out to us. This monocular cue basically says the dimmer something is, the farther away it appears. And shading gives us some type of depth consistency. So for example, in this circle right here, the shading is at the top of this inner circle, whereas the light is at the bottom. So this little circle within this bigger circle appears to be concave. Whereas the shading is at the bottom, the light is at the top. This smaller circle appears to stick out to us. Here's another example of linear perspective. It appears that it's coming together here. And also these two lines, they're actually the same length, believe it or not, but because of the linear perspective, it appears as though one is larger. This is another example of linear perspective. These lines appear to converge. These two parallel lines appear to bend. You get the picture. And then this is kind of a trippy light and shadow monocular example. It appears as though there are these gray dots in between each of the black squares, but it's not. So that's just kind of a cool little trick. It is so, so, so important that you understand all of the monocular cues. I cannot stress it enough. You should be able to give me examples of each of them. You should be able to pick them out in a multiple choice question. You should be able to write about them in a free response question. And you guys are going to be getting practice with this, of course, with the project that you're working on. Make sure you also know the binocular cues. If you have questions, let me know. Remember, the test is moved to Wednesday. You'll get a study guide in class on Tuesday. And remember, for homework on Tuesday night, you are supposed to be taking the free response portion on Edmodo since Wednesday is an early release day.